So basically, we'll just focus on determining the equation. We're not going to graph or anything. Not I won't, at least. So this particular example, a ball is kicked up from the ground, reaches a maximum height of 2.31 at a time of 2.31 seconds, and the height is 35.7 feet. Determine the equation that would model the height of the ball over time. I would strongly recommend putting some axes around this situation, and then just imagine the starting point, right where the ball is kicked from. It's right on the ground, so at time 0, and then you can imagine that this is going to go like this. We're not told that it doesn't hit the ground, so we're going to assume that. We are given the vertex here, and so the vertex is, you got to be very careful how you do this. You want to have the time followed by the height. Okay, so this is my height, this is time, and this is the symmetry. So this is the halfway mark, and the point across your starting point happens to be right on the x-axis. So these are two x-intercepts, right? But this is the one we would focus on, the one that's at the same height as where you started. So you know for a fact that the y value is 0 again, okay? And then the 2.31, right, takes 2.31 to get to here. It will take another 2.31 to get to here. So we just take that, multiply that by 2, and what is that? 4.62? 4.62. 0. There you go. There you have your 3 points. That is usually worth a mark. Getting that third point is worth 1 mark. And remember, let me rephrase this question and make another scenario out of it. They could have said you kick it right from the ground, you kick it up, reaching a maximum height of 35.7, and then it lands 4.62 seconds later, right? You're like, oh, I don't know this. I don't know this part. How do I do that? Well, you just take this time and split it in half. You divide it by 2 to get the midpoint, right? So always remember, it's not always times 2. It could be either or, okay? So make your table, time and height. Make sure you don't mix up time and height. I get 35.7, 2.31s all the time. Like this is mixed up. So you just have to make sure time comes first. So we've got 0, 0, 2.31, 35.7, and then 4.62, back to 0. We put this into L1. We put this into L2, which means this is my x variable, my y variable. We're assuming it's a parabola. It's a quadratic, so stat, calc, quadreg. And we come up with our equation. Marinelle, did you perform the regression? Did you do the regression? Can you give me, is it a pre-equation or does it have a lot of decimals? Can you give me can you try to read it out for me? Putting you on the spot, I know. Yeah, x squared, yeah. X plus 0, right? Because we're starting it, so this is it. Anybody else? Can you confirm this? Yeah, okay. Confirmed. I got 3 nods, and then I'm good, right? So what's the domain and range? I would argue that it's actually fairly simple in this case. We've got everything we need. From time 0 to time 4.62. From height 0 to 35.7. So this one, you may have to find the x-intercept if you didn't know it, right? If this hits the ground, but this wasn't a point that you actually previously found, you may have had to find it. So be ready for that. Let's keep going. I'm going to skip. We're going to go to 60. I don't know if some of you may recognize this. Anybody recognize this question? No? I've used it. I have used it in grade 11 at one point. I'm not sure if I did with you. This is an old exam question, actually. I found that it threw a lot of students off, even though everything was right there. Everything was right there. So can you read this? Right? And then determine the equation that models the shape of this arc. It says express coefficients to 3 decimal places. The exam actually stated that. Everything has to be written to 3 decimal places, all the coefficients. So try to come up with 3 points that you see, or you may have to find some of them, and then make your table here and come up with an equation. Let's do this in like 2 to 3 minutes if you, that's all it should really take. All right, let's see here. We're speaking parabolas, right? So I think I have a joke for parabolas. What do baby parabolas drink? Quadratic formula. Do you remember the quadratic formula? I did mention it, right? When we did the when we solved factorial equations, right? To find your possible answers, you could use the quadratic formula. So tough crowd. Anyways, let's look at this arc. What's missing here that I've normally been giving you? Have you noticed that you have really no idea how tall, like what the highest point is? There's no vertex here. So I'm going to put at the very top here. I like to have a little subheading here. No vertex. That's okay. They will still have to give you enough information to come up with 3 points because you need a minimum of 3 points for a parabola. So the gateway arc in St. Louis is approximates a parabola. Stephen learns that the arc is 192 meters wide. So that's important. That is right there. It's part of the diagram already. At 2.5 meters from the starting point, Stephen measures the height of the arc to be 10 meters. That is actually a full-on point. I don't know if you. This is a point right there, and it's very close here. It's all very crowded, but they're basically giving you this point on the parabola. This point has coordinates 2.5 and then a height of 10. Right? Obviously, we would do horizontal distance and then height second. So they give you that point. They also are giving you this point right here. Anybody venture to guess what this point is going to be? 0, 0. Remember the power of 0, 0. Don't underestimate that. And which other point do you think you can find? Let's look across the one they're giving us. Let's do this. Hey, that one right there. Okay. So I'm going to use a red pen for that. Don't forget the symmetry part. You can always, not always, but in this case, you would know this coordinate. Horizontal distance is 192, and the height is back to 0. So this is your third point. Right there. So some of you might have been, maybe, and rightly so, you might have been like, well, I know that there's probably one across at a height of 10, which is true. But we don't know what the horizontal distance, or maybe, did somebody take away 2.5 on this end? Yes, that should still work. I didn't see that at first. Yeah, it's symmetrical, so that would also work. So what are we at then? 189.5? 10? Yes, yes. Let's see if we get the same answer. We will. I'm fairly confident. But distance and height, so 0, 0, 2.5, 10. Okay, so you're just good students. You just learn and go beyond what I teach you. That's exactly what we want. Okay, there you go. So stat, calc, quadreg. If I enter this, according to my key, I get negative 0.021x squared, because they wanted the three coefficients, right? Three decimals, plus 4.053x. Is that what you get? Yeah? Okay. And it's plus 0, but be careful, because this calculator sometimes likes to be so precise that it will give you a number, but it will have an e to the negative 10 or negative 9. Don't fall for it. It's 0. We know that our y-intercept is 0, okay? So watch for that. If you do some of the homework questions do have that issue, it comes up. So just be mindful of that. So the maximum height of this arc, obviously we go second trace max. I think I will just give you the answers here. That is, the coordinate is actually 96, 194.53. So max height is 194.53. We are in meters. Okay, 194. This one here is 157.30. You can just write down the answers. And this one, this is a delta distance scenario, and the delta distance is 52.48. You got to find the two instances where 180 or above is happening, which is this, or the two instances, and when you subtract it, you get this many meters. You will need paint for. So I'm just giving you the answers there because I was more interested in you actually coming up with the equation. That is it. That's all I wanted to do today. And just keep in mind, I posted the key, so I asked you to go to starting on page 64. I'm just going to take you there and just show you briefly. I keyed everything and posted. Right? So if you go to 64 and on, you've got various types of regression. So you've got a linear. The first one is linear. And I do tell you to write a table including at least 4 months. So basically you're creating 4 points. Even though with linear you only need 2. Linear, you just need a minimum of 2. For quadratic, you need a minimum of 3. For cubic, you need a minimum of 4. But I just go and ask you to make 4 regardless. You'll be safe if you do that. If you always make 4, you can't go wrong. You will be able to perform the regression. Okay. And I do a bunch of domain and range situations. So if you want more practice on this kind of stuff where you make your own question, your own points, that's the way to go. Okay. I will also say this. I will say that fencing is not going to be on this quiz. There is a quadratic regression where you have to make your points regarding fencing. We're not going to have that on the quiz. So I will try to squeeze that in next week at some point. All right. I will also show you that what I've posted and just explain. You're going to get a bunch of this. You can hear me. So Quest review material. So I posted a bunch of pages already. If you wanted to get started, there's more review here. These are all in your booklets. You just go and work through some of those questions. Some questions grab your attention, you go for it, right? And so 70 to 74 and 76 to 79 actually is called test review key. then this is what we did. This is what I posted yesterday. So making your own points, 64 to 69. So 64 to 69, 70 to 74, 76 to 79. So that's all kind of reviewing regressions. I will say this as well. I will post the exponential. So this, I'm going to post this after, like, as you're writing your quiz tomorrow, I will post the videos, the one video I want you to watch to already start our chapter 7. Okay, I know I mentioned it to most of you already, but it's important for you to get started on that. One more thing here. In your part of this booklet, what did I want to mention yet? Oh, if you want to focus your energy on word problems, okay? So you know how at the beginning I made you graph functions in all 4 quadrants, like no context. I need you to understand that. I need you to understand the fact that when there's no word problem attached to it, that it's all 4 quadrants. I need you to be able to understand the behavior in general, but most of it is going to be focused on word problems. Okay, regressions. Some of it is going to be make your own points, but a lot of it is going to be here's your equation, here are the points, make your equation, and then of course you're going to have to make your own as well at one point. Okay, so just keep that in mind if you want to focus your attention on that. That's that. Okay. So we are told that they'll never trick you on this. So if the table is horizontally, we know that this will be x and this will be y. If it's vertical, then the left is x, the right is y. So we know that. Which means that in this particular case, every single point is going to be time and depth, okay, because of that. So the above data is the depth of water at a tide monitoring station in Vancouver. Graph the data on your calculator and determine the degree of the polynomial that would best fit the data explained. So I went ahead and entered all these points. So a couple of things here. You could go graph, nothing happens. You could go zoom stat. Oh, I didn't. I actually meant for plot 1 to be turned off. Let's do that for now. I kind of want to walk you through what could go wrong. That's basically my intent here. So I'm going to go zoom 6. This is a standard window. You go ahead and enter your points, and then you're going to go zoom stat, right? Nothing's going to happen. Why? Because plot 1 is turned off. So if you want to use zoom stat, you have to have plot 1 turned on. I'm going to go back to zoom stat. There you go. This is definitely not a quadratic. If you had this shape, you could argue it's a quadratic. But as soon as there's an indication that this is going back up, like even if you had that, you would probably have to say this is I would say it's a cubic. It's a degree of 3. If there's any indication that it's turning back the other way, it's cubic. So I would say the scatter plot indicates 2 turning points. Therefore, a cubic degree, because that's what it's asking, degree of 3, cubic regression would best model the scenario. Okay, there you go. So 1 mark for that. Find the equation of curve of best fit. So we got to go stat calc cubic regression, and then you go same as always, right? Alpha trace. So there we go. And you definitely want, if you round to 2 decimals, that's fine here because you're going to get 0.01. So regardless of what you did, you'll be fine. Stat, calc, cubic, reg, and here it is. I'm going to go 0.009 x cubed minus 0.325 x squared. Make sure you go y equals, okay? That's a half mark deduction if you don't. So you got to make sure you go with that. And then plus 3.845x minus 10.138. So obviously this would be 1/4 if you round to 2 decimals. That would be 3.8. 3.85 if you round to 2. So yeah, just make sure you get that right. So that's our mark there. Using the equation, find the maximum predicted depth at the high tide during the day. So emphasis on during the day. So we're going to graph this. There it is. Beautiful. I would still want to, I don't think this is a perfect, I still want to see my axes. So I'm going to go negative, I don't know, 5 x min, and y min I'm going to go -5 as well. There we go. So you see that it starts somewhere down here and goes up there, but let's go y min a little lower. Actually, -10 point, that's my y-intercept. So I'm going to go -12. There we go. Okay. And so the maximum during the day, because remember, daytime would be somewhere in here, right? Somewhere in here would be daytime. So we're gonna go find that max, because it does go higher. Do you notice that, right? It keeps going higher. In fact, my X max, I'm gonna go to 25 because it's a 24-hour cycle more or less. So it does go up higher, but during the day would be here somewhere, the data that you're given. So second trace max, right? And I will focus in on that little cap there. And so I go second trace max, and the point I'm getting is 9.43, and then it's 4.39, right? So 4.39 meters is the answer there. Next, use the equation to find the maximum predicted depth at the low tide during the day. Why did I say maximum predicted depth? Did this puzzle you or what? Should be the minimum, right? Yeah, I was hoping for that to say it, but obviously it didn't translate. So we're looking for the min there. So second trace min, you go to the left, enter, and you go to the right. So when you do these types of questions, once you have your equation, everything is based on the equation, on the curve, not the points, okay? So second trace min, I'm going to write this down just in case we're asked to graph this later on, right? You know the exact point, or they might ask for one of the values later on as well. So lowest depth would be 3.27 meters. There we go. Using the equation, find the time or the times where the depth is 3.8 meters. So we're going to go y equals, we're going to let y2 equal 3.8. And so I'm going to go find all three of those. So y2 is equal to 3.8. Second, trace 5. Chicken scratch, right? So I'm just going to give you the answers. 7.03, 3.8 is one of them. Then it's 12.74, 3.8. And the third one is 18.11, 3.8. So I believe this is very tricky because the times, it doesn't ask for how long, like, so you had to do some converting here. What? Right? So this would be 7 something. So you got to go 0.03 times 60. Right? So we're going to go 0.03 times 60 would be 02, 2 minutes, right? Let me see, 0.3 times 60, 1.8, which is 2 minutes approximately. And then 0.74 times 60 is 44 minutes approximately, if you round. And then 0.11 times 60 would be 7 minutes rounded. So the times would be 7:02 a.m. Then we don't need to do a.m. because it's a 24-hour clock, right? And it's 12:44. And then it's 18:07. So these are the exact times. So if you didn't do the conversion, just take off half a mark. But if you do have all of these three, you get a mark still. I know. What? What's the depth predicted at 16:30 p.m.? How would you type that in? 16.5, yes. 16:30 is 16, and then just take the minutes and divide it by 60. Right? So that is 16 and a half, which we can just go 16.5 like that. So this is what you enter into your x value. So second, trace x is equal to 16.5, y is equal to 3.31 meters. Did anybody go 16.3? Nice try. It happens. What is the depth that is predicted for 11 p.m.? This is a valid prediction. 11 p.m. is what? How do you turn that into a 24-hour clock? You just go plus 12, correct? So that'd be 23. Right? So we're really just after that one. So we're going to go second, trace 1, x is equal to 23. What do you get? 10.68. I feel like I needed to give you a bit more info to accurately be able to answer this, but this is not reasonable anymore, right? The tide kind of goes like if you have a max, where is it, 4.39, it would kind of stay with between this and this, right? The tide would go between this and this. After a certain time, this model doesn't work. Not realistic during nighttime. This one only works during the day in our specific. So you know what? If you just say something like it's not realistic, the depth is too great, it varies too much. So if you have the 10.68, I give you a mark, and then the justification another half. So you've got 7 on this page as far as I know. 1, 2, 3, 4, 5, and 3. So this is 8. Sorry, this is actually worth 8. On the back side. Sketch the following. Has a degree of 3, 2 turns, negative leading coefficient, 3 x-intercepts. So right off the bat, we know it's a cubic, and it's got a negative. So we're expecting something like this, but it has 2 turns. So we need to be a bit more aggressive with our turns. Okay, so this for sure I would expect something like that, and then you just introduce. And you have to be careful, right? If you want 3 x-intercepts, it better cross like this, right? You want 1, 2, 3, and just make sure this doesn't look like it's going back in, right? So there you go. That would be all I would need for that one. And remember, it could just go like this, touch it there, and then go back. This would have 2 x-intercepts. 3 x-intercepts. So this could also just have 1 x-intercept. So watch out for that. Understand, like when I give you that chart at the beginning of polynomials, like constant, linear, understand that, right? Because I will ask you, don't spend too much time on it, but understand that, right? A parabola with 1 x-intercept, negative leading coefficient, y-intercept of -3. Let's see how I make this work. 1 x-intercept. So I'll just make sure it touches here. That would be my vertex, and then it goes through -3 like this. So make sure you curve it. So this is 0, -3 there. That would be okay. If you have a variation of that, of course you can be on this side and turn like this, have the -3 there. That is fine as well. So either one of them will give you, so 1.5 for each, I think, yes. So 3 marks. So 8 and 3, that's 11 total. Just make sure your name and last name is on there. I want to give this back to you, so I'll take it, and the rest of the class is review.